today we're going to discuss how to solve quadratic inequalities. But let us first define what a quadratic inequality is. A quadratic inequality in one variable is an expression in the form ax squared plus bx plus c is greater than 0. The only difference with a quadratic equation is the symbol used. Instead of using an equals 0, we used here a greater than symbol. And aside from using a greater than symbol, we can also use less than, greater than or equal to, and less than or equal to, which we call as inequality symbols. So now let us try to solve a quadratic inequality. If, like for example, we have x squared minus 5x plus 6 is greater than 0, how can we solve for its solutions? Remember that in a quadratic equation, the number of solutions or the maximum number of solutions that we can get is 2. But here in a quadratic inequality, we can get greater than 2 solutions, or we can actually get an infinite number of solutions. So let's now try to solve this. The first thing we should do is to write this as an equation. So we will change the inequality symbol to equal symbol, and this will become x squared minus 5x plus 6 equals 0. And the next step is to get the factors of the trinomial x squared minus 5x plus 6. And this will become the quantity of x minus 3 times the quantity of x minus 2 equals 0. So again, we wrote 2 parentheses, and then we get the factors of x squared. These are x and x. And then we also get the factors of 6 that when we add will give us negative 5. And those are negative 3 and negative 2. Because negative 3 times negative 2 will give us positive 6. And negative 3 plus negative 2 will give us negative 5. So we have to remember these factors because we will be using them later on as we proceed. Next is to solve for the value of x. So we will write these two factors as an equation equal to 0. So this will become x minus 3 equals 0 and x minus 2 equals 0. Solve for x. So we're going to have x equals 3 and x equals 2. So these values of x will be used as we proceed to our discussion. So as you can see here in this illustration, we have 2 vertical lines and 2 horizontal lines. And if you'll notice, we wrote the values of x above the vertical lines. We have 3 and 2. So we took them and wrote above the vertical line, in which we wrote first the smaller value of x, which is 2, followed by 3. And on this side, on the left side of this illustration, you can see the factors of the trinomial x minus 3 and x minus 2 in any order you'd like them to write. Alright, so again, above the vertical lines, we wrote the values of x, and on the left side, alright, we wrote the factors of the trinomial. And then if you see here, we have zeros and signs written in blue. So how did we do that? So let's take the values of x, 2 and 3. Let's start with 2. So we will be thinking which among x minus 3 and x minus 2 will give us 0 when we substitute 2. So that will be in x minus 2. If we will substitute 2 to x minus 2, this will become 2 minus 2, which is equal to 0. So if you'll notice, we wrote here 0 on the intersection of 2 and x minus 2. Alright? And with 3, okay, if we substitute 3 to x minus 3, this will also be equal to 0. So we're going to have here 3 minus 3, and that is 0. So we wrote 0 on the intersection of 3 and x minus 3. So that is how we will do that. And if you'll notice, our zeros are not shaded, okay, because shade has something to do in solving quadratic inequality. So let's go back to the symbol used. Our symbol in the original inequality is greater than. Alright, so remember that if the symbols used on the given are greater than or less than, our zeros will not be shaded. But if the symbols used have a line below which will denote an equal to, or if the symbol used are greater than or equal to and less than or equal to, these zeros will be shaded. I hope you understood that. It's because if the zeros are not shaded, it means that these numbers on the vertical line are not included as a solution to our given inequality. But if these zeros are shaded, it means that these numbers above the vertical line are solutions of the given quadratic inequality. By the way, I will be giving you more examples for you to be able to understand this lesson. So now let's proceed. So again, we have here zeros on the intersection of the expression and the value of x that will make the expression equal to 0. And again, remember on your number line that if we have a 0, the signs of the numbers on the left side are negative. That is why you can see here that we wrote negative symbols on the left of zeros. And on the number line, the signs of the numbers on the right side are all positive. That is why on the right side of zeros, you can see positive symbols. Alright? Now, the next thing we should do after writing the negative and the positive symbols on the left or right side of zeros is that we multiply the signs vertically to get these symbols on the bottom. So, if we're going to do that, we're going to have negative times negative. And negative times negative will give us positive. That's why we have positive here on the bottom. And then negative times positive will give us negative, because any numbers or any negative numbers multiplied to positive numbers will give us negative. That is why the product of the sign is written here in the bottom, which is negative. And then positive times positive, when we multiply two positive numbers, that will give us positive. Alright? So we will now focus on the symbols on the bottom. Positive, negative, and positive. Because we will think which among these symbols we will be taking. So later on, we will choose which among these signs are we going to use or are we going to take. Should we take positive or negative? Let's see. So what we're going to do for us to decide is to go back again to the inequality symbol. Alright, here. So the inequality symbol again is greater than. So those symbols denotes or represents symbol. If the symbol is greater than or equal to, we will be taking positive sign. But if the symbols used are negative or less than rather, or less than or equal to, we will be taking the negative sign. And since here in our inequality, the symbol used is greater than, so it means that we will be taking the positive sign. So let's go back here at the bottom. We will be taking the positive sign. So this one and this one. Alright. So we will be taking the numbers on the left of this one, of this number, on the left of 2, on the number line. So if this is the number line, alright, so this is the 2 vertical lines, and here are 2 and 3. Okay, so as you can see here in this illustration, positive is written on the left side of 2. Alright, that's why the left side of 2 in this number line is shaded. It means that all of the numbers on the left side of 2 are solutions to our quadratic inequality, as well as the numbers. So if this is 3, and here is the positive sign, we will also be taking the numbers on its right side. So we can also say here in this number line that if this is 3, we shaded the right region of positive 3. It also means that the solutions of this quadratic inequality are also the numbers on the right side of 3. Okay, so again, 2 and 3 are not included because 0 is not shaded. Alright, so if we're going to write this as a notation, it means that the solutions of this quadratic inequality are the numbers from 2 below, or the numbers below 2. 2 is not included. So the numbers below 2. So until the negative infinity. Union, it means we're going to combine with the numbers from 3 until the positive infinity. So again, the solutions of this inequality are those numbers on the left of 2, okay, until the negative infinity, okay, added with the numbers on the right of 3 until the positive infinity. If we will take integers from this notation, okay, we will have 1, 0, -1, and the numbers on the negative infinity. So again, we did not include 2. So the next number, the next integer lower than 2 is 1, followed by 0, -1, -2, -3, and so on and so forth. And the numbers, or the numbers that will represent this notation, okay, are, or integers greater than 3. So we'll start with 4 until the positive infinity. So 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Alright, so the solutions for this quadratic inequality is an infinite number. Alright, where the numbers between 2 and 3 are excluded. Alright, the numbers between, so the numbers here, the numbers between 2 and 3 are excluded. Okay, including 2 and 3, they are not solution of this quadratic inequality. Only those numbers on the left side and on the right side, or on the left side of 2 and on the right side of 3. If we're going to check, like for example, if we will pick any numbers here on this region. Like for example, we will take 1. So 1 is less than 2, right? 1 is included here in this region. Or if you see, we take note of 1 here as a solution for x. So let's check if 1 is a solution, okay, to our quadratic inequality. Whichever you'd like to check. You can also use 0, -1, 4, 5, 6, 7, or any number that are on the left side of 2 and on the right side of 3. So let's check if x equals 1 is a solution to our quadratic inequality. So again, we copied the original given, x squared minus 5x plus 6 is greater than 0. And then we substitute 1 to x. So x will become 1. So this became 1 squared minus 5 times 1 plus 6. Is it greater than 0? So the square of 1 is 1, and negative 5 times 1 is negative 5. We copy 6. Is it greater than 0? Negative or 1 minus 5 is negative 4. Negative 4 plus 6 is positive 2. Now we have positive 2 as the answer for this, and then we copied greater than 0. Let's check. Is 2 greater than 0? Is the number 2 greater than 0? Yes, of course. 2 is greater than 0. So we can say here that this is true or this is correct.